Algebra 1, Unit 2, Lesson 1, Writing Expressions Using Variables. In this lesson, we want to switch between mathematical and verbal expressions. We want to write algebraic expressions for real-life situations and evaluate those, and use units to check whether an expression that we wrote is valid or not. So a variable is a symbol, usually a letter, that we use to represent unspecified or unknown numbers or values. An algebraic expression is an expression that consists of one or more numbers and variables joined together by one or more arithmetic operations, adding, subtracting, multiplying, dividing, squaring, and so on. Verbal expressions in English can be translated into algebraic expressions using these. So if we have the word sum, which means addition, then you have two things you add together called the add-ins, and they give you the sum as the answer. The difference, of course, is from subtraction. Most of these you don't have to know. You don't need to know minuend and subtrahend, but when you take the first number, that's the minuend, and subtract the subtrahend, you get the difference. So the important words here are the sum, the result of adding, and the difference, the result of subtracting. Product, you need to know is for multiplication. For this one, you do need to know the factors. The factors are the numbers that you multiply, and then the product is the answer for that. And then for quotient, which comes from division, usually you don't need to know dividend, but you do need to know that the divisor is the one you're dividing by, and then the quotient is the answer to that. Other verbal expressions that we have that are important to know is, it will be important for us to know whether there's a sign like a less than sign, or whether it means subtraction or adding or whatever that is. So I have three things here. Two of them mean subtraction, but one of them means a sign. So one of the things is whenever there's a verb, usually it's a verb to be, like is, was, are, those signal a sign of some sort. Is less than implies the less than sign. So it needs a verb and then is less than. M less than n, you're taking m less than n, so you're starting with n and then subtracting m. Watch out for this one. This is the one that most people make a mistake on. When we say m less than n in English, it means n minus m. The other two, m decreased by n and subtract m from n, those people usually don't have as much trouble with, but again, sometimes the thing you mention first comes first, and sometimes the thing you mention first comes at the end. So make sure that you know what the English means. M is more than n. Again, that verb is signals that there's going to be a sign of some sort. In this case, is more than means the greater than sign. M more than n without the verb means n plus m, or m plus n, because you can add in either order. M is n, again, there's the verb, indicates the equal sign. Twice a number n means to multiply by 2. 3 times a number means 3 times that number, where we write multiplication by writing the two things next to each other. So if you have a number and a symbol, writing them next to each other means multiplication. M divided by n, that's m first, and then you're dividing by n. If you're doing long division, that means m is on the inside and n is on the outside. The quotient of m and n also means m divided by n. The square of a number, or a number squared, means n to the power 2. The square root of a number, we've seen, is the square root of that, n. A number cubed, or to the third power, is n cubed. A number to the mth power, n to the m. And of course, n squared means n times n cubed means n times n, as we've seen previously. Quantity implies parentheses. Is, as I've said, implies a sign of some sort. We're not going to use those at the moment. And then, as I said, the and indicates the parts of a sum, a difference, a product, or a quotient. So as examples, it says write algebraic expressions for each verbal expression. The sum, so we have to know that means adding, and then the and tells us the components of a number and 4. We don't know the number, so we need to specify it by a variable. I picked x plus 4. 5 less than a number, again, less than means we're going to take this 5 and subtract it from the number we're given, so that's n minus 5. Half a number squared times another number, that means we need two variables. So there's one number and then there's another number. So I picked x and y. It says half a number squared, so that's a half of x squared, times, so we're multiplying by y. And again, because it's multiplication, we simply write the things next to each other. 8 more than the product of x and y. So we have the product of x and y, meaning we're going to multiply the x and the y, and then 8 more to that, we're then going to add 8 to that. The product of 8 and the sum of two numbers. So now the 8 and the sum are the two things being multiplied together because the and is connecting 8 and the sum. That will now mean that we need parentheses around the sum of our two numbers, x and y. 8 times the sum of two numbers, also the same thing. We have a sum of two numbers and then we're multiplying by 8. The sum of 8 times a number and another number will now sum. The and tells us the two parts of that. There's 8 times a number and then another number. So we have 8x and y. So that's the sum of those two things. 3 times a number to the fourth power, 3 times x to the fourth. The quantity 3 times a number, so that now means 3 times a number, which I'll call x. That whole thing raised to the fourth power would be 3x all to the fourth. So that would be a 3x times a 3x times a 3x times another 3x. So there would be 4 3's multiplied and then 4 x's multiplied in that as well. Write a verbal expression for each algebraic expression. So here you're given an algebraic one and you want to find a verbal one. So we have 3 more than twice a number squared. We could say the sum of twice a number squared and 3. In this one we have two different numbers. So there's the product. They're multiplied because they're written next to each other. So the product of a number squared and then a different number cubed. This is the quotient because we're dividing. Anytime we write a fraction bar like that, that's division. This is 3 times a number, and then we're dividing by 4, so we could say 3 times a number divided by 4, or it's the quotient of 3 times a number and 4. Again, the one that's listed first is the top thing, the one that's listed second is the bottom thing. This is subtraction, so we could use the word difference now. That's the difference between a number squared and twice that number. Again, if it had been a different number, we would have had to say a different number. This implies it's the same one, so we used an x for both of them. For this one, we have two different symbols, so we will need to say another number. So this is the sum of 5 times a number cubed and 3 times a different number. To write an algebraic expression for a realistic situation, I will require that you tell me what the variables are because they actually must represent some quantity in what you're talking about. So variables have to represent something that we can tell in words what they are. Then you need to think about how they're connected and write the expression. So Sara has some money saved and buys a $3 chicken shawarma sandwich every week for some weeks. Write an expression to show how much money she has left. Well, to do this, we need to know how many weeks she buys the shawarma and the amount of money she had saved to begin with. So those would be our two variables. The number of weeks she buys the shawarma, I'm going to call x, and then the amount of money she has saved at the beginning is y. So how much money does she have left? Well, she starts with y, and then she takes away $3 every week, so she would take away 3x from that, because if she bought for 2 weeks, we would say take away $6. If she bought for 4 weeks, we would take away $12, so we have to multiply the 3 and the number of weeks that she bought them. A decorative pencil costs $1.50 and a notebook costs $3.50. Write an expression for the cost of buying different numbers of pencils and notebooks. So now we don't know how many pencils she bought and we don't know how many notebooks are bought. So those are our two unknowns. We'll let x be the number of pencils and y is the number of notebooks. You might also use p as the number of pencils and n as the number of notebooks so that the variables make sense to you in terms of the question. And then the cost would be what? Well, if we buy 2 pencils, we would have to pay $1.50 times 2. If we bought 5 pencils, we would have to pay $1.50 times 5. So it's going to be $1.50 times x, however many there are. And the same for the notebooks. If I bought 2 notebooks, it would be $3.50 times 2. If I bought 4 notebooks, it would be $3.50 times 4. So I have to take $3.50 times the number of notebooks that I buy. And then, of course, I have to pay for both of them together, so I have to add those two things together. Dana bakes some brownies. Dema bakes 20% more. They sell the brownies for 25 cents each. Find expressions for the number each baked and the total income if all the brownies sold. So first we know that Dana bakes some unknown number of brownies. And then we're told that Dema bakes 20% more. Well, 20% of that amount is 0.2 times that. And then she sold that much more, so we have to add that to what Dana baked, which was X, to find the total. And there would be 1 here, plus that 0.2 is 1.2x brownies. Together they can make, well, Dana makes this and Dema makes this, so there's x plus 1.2x. That's a 1x plus a 1.2x. You add those numbers in the front and get 2.2x brownies. Then what would their total income make? Well, they're going to make 25 cents for each one. This is the number of brownies. We multiply that by 25 cents each, and then we would get 0.55 times whatever the number of brownies that Dana would bake. Now we know that dimensional analysis can be used to find units. It can also be used to make sure that an expression is valid. So if I split $90 among X people, what would be the units for that? Well, we have dollars at the top and we're dividing by a number of people, so the units are dollars per person, or since when you do it, it's for one people, so you would say a person instead. If distance d is in miles and time t is in hours, then what are the units for d over t? Well, if you attach the units, this is miles on the top and hours on the bottom, so that's miles per hour. If someone went a distance of 100 miles and then continued on at a rate of 12.5 miles per hour for t hours, what are the units of this expression? Well, now if we attach the units, this 100 was miles, this 12.5 was miles per hour, and then we're multiplying by t hours. The hours on the top and the bottom will cancel, and we're adding miles with another miles from this expression, so the total will be in miles.